Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve average value, RMS value, form factor and peak factor problems. So in that first problem, determine average value, RMS value, root mean square value, form factor and peak factor for sinusoidal waveform. So here what is the sine wave? Sine wave means this is the sine wave. So here sine wave, here this is omega t and this is the v of t. So v of t sine omega t is 0, pi, 2 pi, 3 pi and 4 pi. Total 2 cycles here. So v of t equals to sine wave equation, v of t equals to Vm sine omega t. Now here Vm sine omega t, it follows, this is the sine wave. Now here, so here average value formula, average value equals to area under the curve divided by total time period. Here total time period is 2 pi here. Time taken to complete one cycle is known as time period. Here, so up to 2 pi is time period and 2 pi to 4 pi is the second cycle. So time period is here 2 pi. First average value formula is for symmetrical waveform and asymmetrical waveform. What do you mean by symmetrical waveform? Symmetrical waveform means positive off cycle and negative off cycle must be same. If it is not same means that is asymmetrical waveform. Here in this is a positive off cycle and this is a negative off cycle. So same cycle 1 by 2, 0 to pi up to 0 to pi positive off cycle and pi to 2 pi negative off cycle is same. So it is a symmetrical waveform. For this case, average value equals to 1 by time period by 2, 0 to pi, 0 to t by 2 f of t dt. For symmetrical waveform, asymmetric, this is for symmetrical waveform, this t by 2 up to t by 2. For average value for asymmetrical waveform, so that is equal to 1 by t 0 to t f of t dt. So here we have two formulas for symmetrical waveform and for asymmetrical waveform. For symmetrical waveform, complete of one alteration consider, and for asymmetrical waveform, complete one full cycle consider. Now here total time period is 2 pi up to here. This is up to time period. This is the one cycle. First cycle, this is the second cycle. First one and this is the second one. Now here time taken to complete one cycle is known as time period, that is here 2 pi. This is 2 pi. Now integrated. Here time period is 2 pi by 2 and 0 to 2 pi by 2 and f of t is Vm sin omega t. So here f of t, f function is here voltage function, that equals to V average value equals to 1 by pi, 2 pi by 2, that is pi, and 0 pi by 2, 2 pi by 2, that is pi, Vm sin omega t d omega t. Here this is the Vm, maximum value of alternating quantity. This is minus Vm. Now, if you simplify this, if you integrate this Vm sin omega t, Vm by pi, sin omega t integration is the cos omega t minus cos omega t. Now, limits are 0 to pi. Now, here, if you substitute that limits in the cos omega t, cos pi minus cos 0, that value is 2, minus of cos pi minus cos phi, this one. So, minus of cos pi minus of cos 0. This is minus 1, minus 1 into minus 1, that equals to 2. 2 into Vm by 2. Now, here average value equals to 2 Vm by pi. This one. Average value we determine here. This one. First one completed. Next, average value. RMS value. RMS value means root mean square. For this case, complete for symmetrical and asymmetrical, Consider for full cycle. So same V equals to Vm sin omega t. This is V of t. This is omega t. Pi, 2 pi, 3 pi, 4 pi, 0. This is Vm. So for RMS value, for symmetrical, both symmetrical and asymmetrical waveforms, consider complete full cycle. Here up to 2 pi consider. Now for this case formula, FRMS equals to 1 by T 0 to T above T square dt. Root mean square value. So here f of t function is a V of t function and t equals to 2 pi. Substitute in this VRMS equals to square root of 1 by 2 pi 0 to 2 pi Vm sin omega t square d omega t. Now here Vm square sin square theta here equals to sin square theta equals to 1 minus 2 cos 2 theta divided by 2. This formula here Vm square sin square theta, sin square omega t equals to 1 minus cos 2 omega t by 2 dt. Now if you simplify this one here, so that is Vm by root 2. Here Vm square by 2 pi. Here Vm square by 2 pi and 1 by 2 omega t 0 to 2 pi and cos omega t, cos 2 omega t integration is sin omega t minus sin 2 omega t divided by 2 into this 2. Now here this is 2 to 2 pi. Complete this value is 0. Why? Because sin 2 omega t, sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0. Multiple of n pi value, sin of n pi value is 0. Here this is pi, 2 pi value 0 and 0 value is 0. So completely you can neglect this one and we have only square root of and Vm square by 4 pi into next 2 pi minus 0. Now here pi gets cancelled and this is the 2 square root. Vm square by 2 means that value is Vm by root 2. This is the RMS value of alternating quantity sine wave. Now we have here average value 2 Vm by pi and RMS value is Vm by pi. Now form factor equals to RMS value divided by average value. Here RMS value equals to Vm by root 2 for this sine wave and average value equals to 2 Vm by pi. Now here if you simplify this one, here pi by 2 root 2, that value is 1.11 form factor. No units for form factor. Next, peak factor equals to peak value divided by RMS value. Here peak value equals to, peak value is Vm and RMS value equals to Vm by, this Vm by root 2. That equals to root 2 only. Root 2 equals to 1.414. Now here average value equals to 2 Vm by pi. RMS value equals to Vm by root 2. Form factor equals to 1.11. Peak factor equals to 1.14414 for sine wave. Now second question. Determine same thing for half wave rectifier output. Determine average value, RMS value, form factor, peak factor for half wave rectifier output. Half wave rectifier. So here half wave rectifier, if you give AC sine wave, sinusoidal waveform to the diode, to the particular load. So V of t equals to Vm sine omega t. So here is the supply voltage. V equals Vm sine omega t. For a half wave rectifier, if you give the output voltage is for sine wave. So first half of cycle, diode will be in forward bias. In the negative half cycle, positive half cycle, diode will be in forward bias, and this output voltage follows the supply voltage, same thing up to 0 to pi. And in the negative half cycle, diode is in reverse bias. In that case, output voltage value is 0. Next, pi to 2 pi to 3 pi. Again, diode is in forward bias, and 3 pi to 4 pi. Diode is in reverse bias, and that value is 0. Now, if you see the output waveform for half wave rectifier output, here this is omega t, and this one is the V of t. Same thing, V of t equals to Vm sin omega t. This one sinusoidal waveform. Here we are giving, this is sine wave as the input for the half wave rectifier. Next, output waveforms. It looks like this. This is Vm maximum, V maximum value, peak value, amplitude up to pi. It follows the supply voltage here, and pi to 2 pi. The output voltage is 0 because of diode is in reverse bias. Next, 3 pi and up to 4 pi. Next, up to 4 pi to 5 pi, it is in forward bias. Next, this is Vm and this is Vm, 0. Here you can write here the omega t value from pi to 0 to pi. That value is V equals, it follows the supply voltage, V equals Vm sin omega t, and pi to 2 pi, this value is 0. V of t value. Now, tell me whether this waveform is symmetrical or asymmetrical. This is asymmetrical waveform because positive half cycle is not equals to negative half cycle. Here this is the positive half cycle, but there is no negative half cycle. Negative half cycle area is 0. So it is asymmetrical waveform. For asymmetrical waveform, while calculating the average value, we will consider complete full cycle. For symmetrical waveform, we will consider for half cycle only. Alteration of half cycle means that is alteration. Up to one alteration only we will consider for symmetrical waveform. Now here the formulas, this is for symmetrical waveform. So don't use this formula because here it is asymmetrical waveform. So use this formula only. In the previous problem, there is a full cycle. So complete full cycle, positive half cycle, and this negative half cycle is same in the previous problem. That is the reason it is a symmetrical waveform. In that case, use this formula. Complete half cycle only up to t by 2 only. Calculate the average value. In case of RMS value, you can consider full cycle. Now use this formula, complete full cycle. Now here the time period. Time period means time taken to complete one cycle. Cycle means complete set of positive and negative values of alternating quantity is known as cycle. Here what is cycle up to 2 pi. This thing also you need to consider here. So up to 2 pi. 2 pi is the time period. This is 2 pi. So pi 0 to pi Vm sin omega t, it follows the supply voltage, and pi to 2 pi value output voltage for half wave rectifier is 0. Next case. Next. So same thing, 1 by 2 pi 0 to 2 pi Vm sin omega t. Here f of t is the V of t. This one voltage waveform. So V average value equals to 1 by 2 pi 0 to pi Vm sin omega t d omega t. Now integrate this Vm sin omega t. Sin omega t integration is minus cos omega t. Vm is common. So minus sin cos omega t 0 to pi. Same thing as we calculated in the previous problem, but only the value is in the previous case, that is 2 Vm by pi, here Vm by pi. Cos omega t, cos of pi minus cos 0. Now here average value is Vm sin Vm by pi. Now RMS value. So for symmetrical and asymmetrical waveform, while calculating the RMS value, consider complete full cycle. So the formula V of t equals Vm sin omega t, f RMS equals to square root of 1 by t 0 to t f of t dt. Here f of t is a Vm sin omega t, t equals to 0, pi, this is a pi, this is a 2 pi, this is 0. So up to here time period t equals to 2 pi, and this is Vm and this is V of t equals Vm sin omega t, this is the omega t. Now substitute in this, V RMS equals to square root of 1 by 2 pi 0 to 2 pi Vm sin omega t whole square, complete this one whole square d omega t. Now here same thing, sin square theta equals to 1 minus cos 2 theta divided by 2. This is the formula, trigonometric formulas. Or cos 2 theta equals to 1 minus 2 sin square theta. So that formula, here sin square theta equals to 1 minus cos 2 omega t divided by 2. So now if you simplify this, in this case Vm by 2, same thing, Vm square divided by 2 pi, this is 1 by 2 omega t 0 to 2 pi. In the previous case also same thing, minus 1 minus cos 2 omega t divided by, this is not cos 2 omega, sin omega 2 divided by 2 into 2. This value is completely 0, 2 pi. In the last problem I explained, this value is 0 because sine of multiple of pi is 0 always. Here sine 0 0, sine pi is 0, sine 2 pi is 0. Now here Vm square divided by 2 into next this omega t 2 pi minus 0, 2 pi minus 0 and square root. Now here this one, here there are two possibilities. Here this is not 2 pi, 0 to pi is here. You can consider here up to 0 to pi one thing and pi to 2 pi plus pi to 2 pi. Pi to 2 pi is this one. So this is 0. Here this is not 2 pi, pi only. Up to pi plus pi to 2 pi value is 0 d omega t. 0 square d square. This one. This is most important. Here 1 by average. Here there are two limits. 0 to pi up to integrate and pi to 2 pi. So here 0 to pi Vm square sin omega t whole square d omega t, and next limits pi to 2 pi. So that value is 0, 0 square d omega t. Next Vm square 2 pi 0 to pi. Here pi means this one. Next Vm square, this is the pi. Pi gets cancelled, Vm square by 4, that value equals to Vm by 2. Now this is the average value, that is Vm by pi, and RMS value Vm by 2, and form factor equals to RMS value. The ratio of RMS value to the average value is known as form factor, and peak factor means the peak value to the RMS value is known as the peak factor. Now here for RMS value is Vm by 2 and this one is the Vm by pi. So that equals to pi by 2, 3.1 4 divided by 2. That value equals to 1.57. Next, peak value is Vm, and this is the Vm by 2 average value, RMS value, that equals to 2. Now here this is the Vm by pi average value for this half wave rectifier output, and RMS value is Vm by 2 only, and this one is the 1.57 and this one is the 2. Next, another case. In the third problem, full wave rectifier output. Same thing, determine average value, RMS value, form factor and peak factor for full wave rectifier. In case of full wave rectifier, we will use 2 diodes. So in this, that full wave rectifier output is looks like this: 0, pi, 2 pi, 3 pi and 4 pi. This is omega t and this is V of t. In the full wave rectifiers, we will use 2 diodes. So in the first half cycle, diode D1 will conduct and D1 is on and D2 is off. In the negative half cycle, in the negative half cycle during pi to 2 pi, D1 is off and D2 is on. So in this case, D2 will conduct and D1 will be in reverse bias. So in the first 0 to pi and pi to 2 pi. In this duration, D1 conducts, D1 is on and D2 is off. So this is the sine wave and 2 diodes, and next output, and D2 is on and D1 is off. Here on condition means forward bias condition and off condition means reverse bias condition. In this same thing, it follows the supply voltage. So V of t equals to Vm sin omega t, and in this case V of t equals to minus Vm sin omega t. Now here tell me to calculate the average value. To calculate the average value, so first step is we need to determine the symmetrical waveform or asymmetrical waveform, whether it is a symmetrical or asymmetrical. This is the asymmetrical waveform. Asymmetric because there is no negative half cycle, only positive half cycle. What is the time period for this particular waveform, full wave rectifier output? Here V of t is sin omega t, Vm sin omega t, this is okay. Next, average value. Average value, this is for symmetrical waveform, but it is asymmetrical waveform. How it is asymmetrical? There are no negative values. Symmetrical and symmetrical means positive half cycle and negative half cycle must be same. In case of asymmetrical waveform, use this formula: F average equals to 1 by t 0 to t f of t dt. This formula only consider. Make sure means while calculating average value, first find out average value. First determine that waveform is in symmetrical or asymmetrical. Now here, what is the time period? Time period means time taken to complete one cycle. Here complete one cycle means not 2 pi is the time period, because up to here only one cycle. So t equals to pi only, not 2 pi. Pi to 2 pi is a second cycle. This is the first cycle and this is the second cycle. So here time period is the pi only. Now here substitute in this. F average means F function is here voltage function. Now same thing, V average equals to 1 by pi 0 to pi Vm sin omega t d omega t. Now here same derivation, Vm by pi minus cos omega t, that is this integration is minus cos t and substitute the limits. So if you substitute the limits, same thing as we discussed in the first problem, sine wave waveform average value 2 Vm by pi. Next, RMS value, same thing, V of t, omega t, this is the Vm, this is pi, 2 pi, 3 pi, 4 pi, this is 0. V of t equals to Vm sin omega t. Same thing, for RMS value, consider full value, full time period up to pi, and t equals to pi, and f of t is the RMS V of t sin omega t, and Vrms equals to 1 by pi square root of 1 by pi 0 to pi Vm sin square d omega t. Same procedure follow. So sin square omega t means 1 minus cos 2 omega t by 2. If you simplify this, Vm by root 2. This one. Now here we got the average value, RMS value, and we know the maximum value Vm. Then we can determine the form factor and peak factor using this. RMS value is Vm by root 2, and this one Vm by 2 Vm by pi. This value equals to 1.1, as we discussed in the first problem. For sine wave, average value, RMS value, form factor, same values, and peak value is Vm, and RMS value is Vm by root 2, this one, and this equals to root 2 means that is 1.414. 1.414. This is full wave rectifier. Now here for sine wave, half wave rectifier and full wave rectifier. Half wave rectifier, full wave rectifier, and this one average value, RMS value, and form factor and peak factor. So same thing, 2 Vm by, this is 2 Vm by pi and Vm by root 2, and next this one 1.11, this is root 2, that equals 1.141. Same thing, 2 Vm by pi, Vm by root 2, and 1.11, and this is the root 2, 1.1414, and here Vm by pi and Vm by root 2, and this is 1.57, and this value is 2. We solve total 3 problems. So for sine wave, for half wave rectifier output, and for full wave rectifier output. Next, this is for sinusoidal type of these 3 problems, sinusoidal type of waveforms. Next for square wave, next triangular waveform, and for trapezoidal waveform. Different types of waveforms, we can calculate the average value, RMS value, form factor, and peak factor. So here determine average value, RMS value, form factor, and peak factor for square waveform. Square waveform means this is the square waveform. So this is time taken t, and this is the V of t. So here V of t equals to, what are the limits here? Limits means here same thing. Tell me this is symmetrical waveform or asymmetrical wave up to here the time p complete one cycle. So here it is a symmetrical waveform. Symmetrical waveform means positive off cycle and negative off cycle must be same. So it is a symmetrical waveform. We can use this formula of average equals to 1 by t by 2, 0 to t by 2, f of t dt. So don't use this formula. In the full wave rectifier and in the half wave rectifier output, we consider this one because the two waveforms are asymmetrical waveform. This is symmetrical waveform like sine wave waveform. Now in this, now here time period is 2. Here time period is 2 means 0 to 1 and 1, 2, 3, 4. 0 to 1, this value is Vm. This one. 0 to 1, this value is Vm, and 1 to 2, this value is minus Vm. Vm and minus Vm. Here peak to peak values Vm minus of minus Vm, that is 2 Vm. During the period. Now we can calculate the average value in two ways: area under the curve divided by total time period, or integrate, use this formula. So here time period is 2, so that equals 2 by 2 means that is the 1, this one, and this one, this is also 2 by 2, and this value is 1. Time period is 2. So up to here complete one cycle and t equals to 2 only. This is the second cycle. This is the second cycle. Now V average equals to 1 by t by 2. T equals to here 2, and this is 2, and f of t equals to Vm only. So here f of t equals to Vm only. Up to here it is a straight line parallel to the x-axis, that is time axis, that is Vm only. Now average value equals to Vm only. Otherwise you can calculate the area under the curve. Area, what is the area? This is the Vm. This length is Vm. This is the Vm, and this length is 1. So area, this rectangular area is Vm into 1 divided by total time period by 2. That is 2 by 1. That is the 1. So for off alternation, t by 2 only consider. Next, average value we determine, that is Vm only, and RMS value. RMS value, same thing, complete one's full cycle. So consider full cycle for RMS value. If RMS equals to square root of 1 by t 0 to t f of t square dt. This formula. Now here f of t is the V of t. This is Vm. This is minus Vm, and 1, 2, 0, 3, 4, and this is t. Now here time period is 2 limits, 0 to 1, that is plus Vm, this one, and this is minus Vm. So this one, 1 to 2, this one, and square this one. Square root of total time period is 2. Total time period is 2 here, and square root of 1 by 2, 0 to t, 0 to 1, Vm square dt, plus 0 to 1, 0, 1 to 2, integration of 1 to 2, minus Vm square dt. Now they simplify this one. Now that is also same thing, Vm. So this is the Vm average value, and RMS value is Vm. So form factor automatically same average ratio of RMS to the average value is known as the form factor. That one is, this is Vm and this one is the Vm, and it gets cancelled. One LHS and numerator and denominator is same, means that value is 1, and peak factor is also Vm, and this one is the Vm, and this is also 1. Same thing, this maximum value is Vm. Now sine wave related problems 3 completed. Next is square wave. Next, triangular waveform. So determine average value, RMS value, form factor for triangular waveform. Triangular waveform means this one. So triangular. So 0 to time axis is x-axis, and this is the voltage axis. Now here this one, the limits, same thing. This is the complete one cycle is up to here, positive off cycle and negative half cycle is same, means that is symmetrical. Now you can use this formula f average equals to 1 by t by 2 0 to t by 2 f of t. Don't use this formula. This is for asymmetrical waveform only. Now here time period equals to 4 because time period equals to 4 because 0, this one 1, 2, 0, 1, 2, 3, 4, and this is 5, this is 2. Now this value is 5 and v of t, and this is delta t. This is sine wave. Here 0 to 1, 0 to 1, here 0 to 1, 0 to 1, 0 to 1, this waveform equals to 5t, and 1 to 2, this waveform equals to 5 2 minus t, and 2 to 3 v of t equals to 5 2 minus t, and 3 to 4 v of t equals to 5 t minus 4. So how to calculate this 5t, 5 2 minus t, and 5 2 minus t, and 5 t minus 4. So now here this is this point 0 comma 0 at this point, and this point is for 5 comma 1 comma 5. This is the maximum value 5. So 1 comma 5. Here we know this straight line equation y2 minus y1 divided by x2 minus x1, that equals to y minus y1 divided by x minus x1. Here 2 points. If 2 points are given in the question, now here for that straight line passing through the 2 points, that equation is x1 and y1 and x2 y2 and x and y. So these are the coordinates x and y. Here x is the time axis, this one x is the time axis, and y is the v of t. X is the time axis and y is the v of t, and x1 y1 is a 0 comma 0, and x2 y2 is a 1 comma 5 and 1 comma 5. If you substitute these values in this y2 minus y1, 5 minus 0 divided by 1 minus 0, that equals to v of t minus 0 divided by t minus 0. Now if you simplify this, v of t equals to 5 into t divided by 1, that equals to 5 into t. This is the straight line equation. In between these two interval, these two 0 to 1, that straight line equation, that straight line passing through origin and 1 comma 5 point. So here in between 0 to 1 limits, that straight line passing through these 2 points 0 comma 0 and 1 comma 5, and x and y axis, or x axis is the time axis and y axis is the voltage axis, that is t. Now here this portion is completed. Next second one. Now here second one, this point. So x in the x axis, y coordinate is 0 2 comma 0. Now here x1 y1, x2 y2, x and y, and t v of t, this one, and x1 y1 is a 1 comma 5, and x2 y2 is the 2 comma 0. Now same formula, use this formula, and this one equals to 0 minus 5 divided by 2 minus 1 is equals to v of t minus 5 by t minus 1. Now here minus 5 into t minus 1, v of t minus 5, v of t equals to that equals to minus 5t plus 5 plus 5, that equals to minus 5t plus 10 is equals to, that equals to Now here that equals to 5 2 minus t. V of t equals to 5 into 2 minus t. This is the equation in between these two points. So in between one time during this 1 and 2 time, during this period 1 comma 2, this period. So straight line passing through 1 comma 5 and 2 comma 0. At that case, this one 5 2 minus 2, 2 minus t. Same straight line passing through this one. So 3 comma minus 5. This value is minus 5. 3 comma 5. Same equation we will get. If you substitute in this also, you will get same thing, 5 2 minus t. If you extend this one, same, it passing through 3 comma minus 1. At that case, so 2 comma 0 and 3 comma minus 5, and next one x axis is that t, and y axis is the v of t. Now if you solve this one, and between this is 0 to 1 and 1 to 2 and 2 to 3 also, we will get v of t equals to 5 2 minus t. If you do that, you will get same value, 2 minus t into 5. Now between 3 to 4, 3 comma 4, x is the 3 comma minus 5, and x1 y1, x2 is, y2 is the, this is the 4 comma 0, 4 comma 0, 4 comma 0. In that case also, now here 0 minus of minus 5 divided by 4 minus 3. Next, v of t minus half minus 5 divided by t minus 3. Now if you simplify this one, v of t plus 5 is equal to 5 into t minus 3. So now if you this is 5 is in LHS side, if it is go to the RHS side, so 5t minus 4, this one in between 3 to 4. Now we have the voltage values. If you know the voltage equation, then only we can calculate the average value. Now here average value, this is a half cycle only you consider for average value, this one, and don't consider this is asymmetrical, not asymmetrical waveforms, it is a symmetrical waveform. Now here 0 to 1, 0, 1, 2, 3, 4, 5, and this is 5 and this is minus 5. Now here time period is 4 up to here, this is the time period. Now integrate the equations. Time period is 4, but here you can consider up to here only. One alteration only consider for average value because it is a symmetrical waveform. 0 to 1, that is 5 of t, this one, and 1 to 2, that is 5 2 minus t. So now if you simplify this one, that value equals to average value. In another way, we can calculate this average value, area under the curve for half alteration divided by half alteration time period t by 2. So area value, this is a 5. So the height is 5 and this length is 2. Half into b into h, triangle, and divided by time period is 2 by 2, that is 1 and 1 by 2. This is value is 2, b value, this length is 2 and this value is 5. This is the 1 and this one is cancelled. You will get 5 into 5 by this one 2.5. Total height is 5 and this is 4 by 2, not, and this is 2.5. Total time period by 2, complete was, this is 2, sorry, and this value is 2. In two ways we got same value. for integration wise or for area wise. Area under the curve divided by total time period for symmetrical waveform. Area under the curve for off alteration and divided by half time period for symmetrical waveform. Here we got average value equals to 2.5. RMS value consider full cycle. Same thing, that equals to 1 by t 0 to t f of t square dt, that is f RMS. Here f of t is the voltage function v of t. Now here time period is 4. Here total we have total 4 limits, 0 to 1 and 1 to 2 and 2 to 3 and 3 to 4. But 1 to 3 same straight line equation, that is same, this one. Then 1 to 3 you can consider same thing, this one. And VRMS equals to total time period 1 by t, that is 4 and 0 to 1, and f of t 0 to 1, this is the 5t square, and this 1 to 2 2 minus t and 2 to 3 3 5 2 minus 3, this one square, and 3 to 4, that is 5t minus 4 square. Now if you simplify this complete this one, that value equals to 2.88. Now our RMS value equals to 2.88 divided by average value equals to 2.5, that equals to 1.15. This is the form factor, means a ratio of RMS value to the average value. Now peak factor equals to, this one equals to 5. This peak value is the maximum value of alternating quantity is a 5 here. Now here this value equals to RMS value is 2.88, that equals to 1 by 1.732, that equals to root 3. Here in the previous RMS value equals to Vm by root 3 we got, that equals 5 by root 3, means that is 2.88. Next, trapezoidal waveform. Trapezoidal waveform means this one. This is t and this is the v of t. V of t. This value is also 5 maximum value, and 0 to 1 1 limit, and 1 to 3 and 1 limit, and 3 to 4 1 limit, and 4 to 5 1 limit. Next 5 to 7 1 limit, and 7 to 8. So for this particular waveform, determine average value, RMS value, form factor and peak factor. That is trapezoidal waveform, trapezium model. So trapezoidal, first tell me whether it is symmetrical or asymmetrical. This is the symmetrical waveform. Positive off cycle and negative off cycle is same. So total time period is t. So t is off cycle is 4, t by 4, that is t by 2, that is 8 by 2 is the 4. So here up to positive off cycle is same and negative off cycle is same. This is symmetrical. So you can use this formula. Now first calculate the voltage equation. Same thing, 0 comma 0, and this is the 1 comma 5. This is a 1 comma 5, and this one 3 comma 5, and this one is 4 comma 0, and this one is a 5 comma minus 5. This value is minus 5. Maximum value is 5 and negative maximum is minus 5, and this one 7 comma minus 5, and this one 8 comma 0. So for all cases, now here v of t equals to, first, so same thing, y2 minus y1 divided by x2 minus x1, that one equals to y minus y1 divided by x minus x1. Here this is t and this is the v of t. Now here if you do this using that points 0 to 1 phi of t, and 1 to 3, this is straight line parallel to the x-axis 5, and 3 to 4, that is uh, 3 to 4, 3 to 4, 5, 5 into 4 minus t, and this one is also same thing, 4 to 5, this is same thing, and 5 to 7, 5 minus 5, this value is minus 5, and 7 to 8, so 5t minus 8, this equation. So substitute that values 5 comma 1 comma 5, 3 comma 3 comma 5, 4 comma 0, 8 comma 0, and minus 5, 7, and minus 5 comma minus 5, and 0 comma 0. Substitute in each step during 0 to 1. Now here average value equals to, this is symmetrical waveform, means you can use this one, and don't use this one. And now here time period is 8. Now here half cycle only, up to 4 only consider, and 0 to 1 5 of t dt, this one, and this one 1 2 3, and use this one, and 3 to 4, and this one. If you simplify this average value and total time period by 2, this one 8 by 2 is, that is 4, 3.75 is the average value, 3.75. And for RMS value equals to, RMS value equals to same formula, 1 by t, 0 to t, f of t square dt, and time period complete full cycle you consider this one, 0 to 1, and 1 to 3 3, and 3 to 5 this one, and 5 to 7 this one minus 5, and 7 to 8 this one. If you simplify this, 9.24, average value is 9.24. From form factor equals to, this is 9.24 for average value, this is a say 3.75. So now if you simplify this one, that is 2.46, and next peak value is 5 divided by 9.24, that value equals to 0.528. Now this is 3.75, sorry, and this is 9.8, average value, RMS value 9.24, and this is the form factor equals to 2.46, and peak factor equals to 0.528 for trapezoidal waveform in this case. Now thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.